this demo case here, this is GuardLink. So what it is basically, like I said before, a sub-Ethernet linking technology for safety devices. And the way it works is they have a single safety relay, 22.5mm wide, that can provide 2 trunk networks, which are these red M12 cables here, with up to 32 of the smart taps hanging off it. So potentially on one safety relay, 64 safety devices hanging off it, all up to performance level E. So with this technology, you have no risk of fault masking. So the way it works is the output from the safety device here, we've got a sensor guard, wires into the smart tap, and the smart tap is doing the diagnostic coverage at that point. So you cannot fault mask. So this is really good for retrofitting to existing machines that have dry contacts on there that won't bring them up to the latest standard. From the smart taps, you'll see they have the 2 green LEDs on each tap. So when the system's healthy, you'll see all the LEDs are green. So you can put these on the outside of the machine and get good visual indication of which device is tripping the machine or not. If I open the sensor guard here, you should see that the smart tap at the top, the top LED goes red, which says this device has tripped on the network. The LED underneath also goes red to say the GuardLink network is not healthy. And then you'll see on every other tap on that network, it also shows a red LED underneath saying that something on the network is not healthy. But the LED above blinks green, so you know the devices hanging off these taps are okay. The M12 cables come pre-made from themselves, so you buy them from 30 centimeters up to 30 meters, so that is the maximum you can have between each tap. So 30 meters, 32 taps, you work it out, it's just shy of a kilometre. There is a Excel spreadsheet that we provide because you have to calculate for volt drop, so obviously that's the issue with running at that kind of distance. So you basically specify what device you're hanging off the GuardLink tap, and it will say, yep, you need to insert a power tap, and that basically boosts the 24 volts back up. Obviously there's a mixture of devices on this demo case here, so we've got a sensor guard, which we call an OSSD output, so we have an OSSD tap to suit. Then on here we've got an E-stop which goes in the middle tap, so press that, you see that's gone red. This is obviously a dry contact switch, so the tap is slightly different, it's called EMSS. So basically all it's doing is, you know, like your safety relay, it's putting test pulses out on the legs for that device, whereas this one obviously doesn't need to because it's an OSSD device. So you just buy the tap for the device. The good thing about GuardLink is these nodes do not need to be programmed. You basically put them in from 1 to 32. When the relay powers up, there's a terminator on the last tap. The first tap it sees is 1 and it goes up to 32. So from a maintenance point of view, if one of them ever fails in the middle of the night, they can go to the stores, swap them out with the same tap and repower it. You don't need to get any programmers out or anything like that. Also, if you need to extend this in the future, simply turn the GuardLink relay off, remove the terminating resistor, then add on the new device, repower, that then becomes the next tap in the address. Obviously going up to a maximum of 32 on one network run. As I said before, the relay can have up to 2 of these networks hanging off it. So you can have 32 on one network and 32 on the other. They operate the same output. So this relay has 2 normally open outputs that hang off the bottom of it. When these devices trip, as you may hear, the relay trips on the safety relay. You can't do separate functions for each GuardLink network. So if you wanted to do zoning, you would run another GuardLink relay on a different network. And then these relays work with, as our GuardMaster relays before, they have what's called single wire safety, where you can link them together and then do and or functions with them together to do your zoning functions. You'll see here there's an Ethernet gateway. So if I go to the HMI here and press Smart Safety, we've now got a reflection of what's happening with the taps on the screen. So if I open this sensor guard here, you should see that the gate opens and the gate closes. If I press the E-stop, again, the taps change state on the HMI. So you can do whatever you wish to do from a top-end SCADA or HMI point of view through the gateway. The gateway itself can support up to 6 of these relays through one connection, so you don't have to buy a gateway per GuardLink relay. The other thing it does, so I've got that going into this HMI here, and I've also got an LZ locking switch here. There's no additional wires, basically just the Ethernet cable here. If I press unlock on the HMI, the LZ has now unlocked. If I press lock on the HMI, the LZ's locked. So again, reducing your wiring in the cabinet, it's basically this, and they communicate together through an optical bus. So there's actually no cabling between these two modules as well. One thing to bear in mind is this is grey to indicate that obviously it's non-safe, it's diagnostic purpose only. So the lock signal is actually a non-safe signal from this to the GuardLink relay. It's not SIP safe also. So if you needed to use this into a SIP safe device, you would have to come out of this relay and into some point IO or into the 5609 IO for the new compact GuardLogics.